What if we couldn't recognize alien life, even if it was standing right in front of us? Think about it. What if aliens don't have faces, no eyes, no bodies, nothing that looks remotely human? What if alien life is something completely different? A strange chemical pattern, a living ocean, or even an intelligent energy system drifting through space? Scientists are now seriously considering this possibility, that alien life could be so different from anything on Earth that we wouldn't even make the mistake of calling it alive. We wouldn't even notice it. And here's the most unsettling part. It's possible we've already seen signs of them, but we dismissed it as nothing more than random space noise. Because the truth is, we're not really searching for alien life. We're searching for life that looks like us. And tonight, we're going to dive into the science behind a terrifying idea, that the real truth about alien life won't come from Hollywood. It will come from the hidden rules of reality itself. So before we begin, make sure you hit the subscribe button, and if you enjoy videos like this, leave a like. And tell me in the comments, do you think alien life will look like creatures or something we can't even imagine? Now, let's begin. Forget everything you think you know about aliens. Forget the green-skinned invaders, the giant black eyes, the flying saucers, and the Hollywood monsters that crash into cities with dramatic explosions. Because if extraterrestrial life is real, the truth may be far stranger, quieter, and more unsettling than any movie has ever dared to show. Scientists are beginning to accept a possibility that feels almost impossible to process. Alien life might exist in forms so unfamiliar that we would not even recognize it as life, even if it was right in front of us. This is not science fiction anymore. It is a serious scientific problem, and it begins with one uncomfortable fact. Humanity has only one example of life in the entire universe: Earth. Every living organism we have ever studied, from bacteria hidden in soil to whales swimming in the deep ocean, follows the same basic biological rules. We are all built from carbon. We all rely on water. We all store information using DNA or RNA. We all descend from a single ancient ancestor that lived billions of years ago. This means every assumption we make about life is shaped by one single planet. That is why many scientists say we suffer from what is called carbon chauvinism, the belief that life everywhere must be carbon-based simply because Earth life is. The famous astronomer Carl Sagan warned that this bias could blind us. If alien life uses different chemistry, different solvents, or different structures, we may overlook it completely. We might even land on a world filled with strange living systems and walk past them like they are rocks, clouds, or meaningless chemical reactions. Now look up at the night sky. On a clear evening, you can see thousands of stars without a telescope. Each of those stars is a sun, and around many of them are planets. Not just a few planets, but billions upon billions. Modern astronomy suggests there may be more planets in our galaxy than there are grains of sand on Earth's beaches. Some are rocky like Earth. Some are frozen worlds covered in ice. Some are ocean planets with endless water. Some orbit two suns at once. Some are so close to their stars that their surfaces may glow like molten metal. The universe is not empty. It is overflowing with possible homes for life. And yet, despite decades of searching, we have found no confirmed evidence of aliens. No radio messages, no alien spacecraft, no undeniable artifacts. This eerie silence creates a disturbing mystery known as the Fermi paradox, named for physicist Enrico Fermi, who famously asked a simple question in 1950: where is everybody? Maybe the answer is not that life is rare. Maybe the answer is that life is common, but it does not look like us.
Maybe the universe is full of living things that do not build technology, do not send signals, and do not communicate in ways we understand. And if that is true, then the greatest discovery in human history may already be hiding in plain sight, waiting for us to learn how to see it.
That thought changes everything. If alien life could be hiding in plain sight, then the real challenge is not finding it, but defining what we are even searching for. Because the moment we admit that life may not resemble Earth life, we run into a deeper question, one that scientists still struggle to answer with confidence. What is life, really? Not life as we know it, but life in the broadest possible sense. What are the minimum requirements for something to be considered alive? NASA currently uses a working definition that sounds simple but carries enormous implications. Life is described as a self-sustaining chemical system capable of Darwinian evolution. In other words, life is not just a creature, it is a process. It is a system that can maintain itself, use energy, and change over time in a way that allows natural selection to shape it. This definition does not mention carbon, it does not mention water, it does not even mention DNA. It focuses on the idea that life is a chemical engine that can copy itself with variation and gradually evolve into something more complex. That sounds reasonable, but it creates an unsettling problem. Many chemical systems can look alive. Crystals can grow, flames can spread, storms can organize into patterns. Even computer programs can replicate and evolve inside digital environments. Yet none of these things are considered living in the biological sense. So where do we draw the line? If we discovered a strange moving structure on another planet, how would we know whether it was alive or simply an exotic chemical reaction? This is why searching for aliens is so difficult. Scientists are trying to detect something they have never seen before, using tools built around Earth biology. For decades, the search focused heavily on intelligent life, civilizations capable of building radio transmitters. That was the dream of early SETI projects, listening for artificial signals from distant stars. But what if advanced life does not use radio waves? What if their communication is based on methods we cannot detect? Or what if intelligent life is extremely rare, but simple life is everywhere? The more scientists study Earth, the more they realize intelligence may not be the main target. Microbial life is far more likely. Single-celled organisms could survive in harsh environments for billions of years without ever developing technology. If the galaxy is filled with microbes, then the universe could be alive and still appear silent. And that brings us to the most important shift in modern astrobiology. Instead of asking, where are the alien civilizations, scientists are now asking, where could chemistry become biology? They are searching for environments that provide energy, stability, and the building blocks of complex molecules. They are studying places where liquid solvents exist, where chemical gradients can fuel reactions, and where time allows complexity to slowly emerge. This new way of thinking has transformed our solar system into a much more exciting place. Because when we stop searching only for Earth-like planets, we begin noticing something strange. Some of the best candidates for alien life might not be planets at all. They might be moons. And some of them are closer than we ever imagined. Moons were once considered dead worlds, frozen rocks orbiting larger planets, nothing more than silent companions in space. But modern discoveries have shattered that assumption.
In fact, some of the most promising places for extraterrestrial life in our entire solar system are hidden beneath the icy surfaces of distant moons, far away from the warmth of the sun. These are worlds within worlds, sealed under thick shells of ice, protecting oceans that may have existed for billions of years. One of the most famous examples is Europa, a moon of Jupiter. From the outside, Europa looks like a cracked marble of ice covered in long fractures and strange streaks across its surface. But beneath that frozen crust, scientists believe there is a vast global ocean. And not just a small ocean, Europa may contain more liquid water than all of Earth's oceans combined. The water is kept from freezing solid because Jupiter's powerful gravity constantly stretches and squeezes Europa, generating heat through friction. This process, called tidal heating, turns Europa into a hidden ocean world, warmed from the inside. Then there is Enceladus, a small moon of Saturn that appears quiet and harmless at first glance. But in 2005, NASA's Cassini spacecraft discovered something shocking. Enceladus is spraying massive geysers of water vapor and ice particles into space. These plumes shoot out from cracks near its south pole, forming a visible cloud around the moon. And within those plumes, Cassini detected organic molecules, salts, and chemical ingredients that strongly suggest the water comes from an underground ocean. Even more disturbing, scientists found evidence that this ocean may be interacting with hot rock at the seafloor, creating the kind of hydrothermal vents that support life in Earth's deep oceans. This is where the story becomes almost eerie. On Earth, hydrothermal vents are among the most alien environments we know. They exist in total darkness, under crushing pressure, surrounded by boiling mineral-rich water. Yet, life thrives there. Entire ecosystems survive without sunlight, powered instead by chemical energy. Bacteria convert sulfur and other compounds into usable energy, and larger organisms build their lives around those microbes. If life exists like that here, then Europa and Enceladus suddenly look less like frozen moons and more like potential biological laboratories. But perhaps the strangest moon of all is Titan, Saturn's largest moon. Titan is covered in thick orange haze and has rivers, lakes, and seas, but these are not made of water. Titan's surface temperature is so cold that water is frozen solid like rock. Instead, Titan's lakes are filled with liquid methane and ethane. It even has a methane rain cycle, with clouds forming, storms happening, and rivers carving channels through the landscape. Titan is essentially an Earth-like world operating on completely different chemistry. If life exists on Titan, it may not use water at all. It may use methane as its solvent. It may build membranes and structures from hydrocarbons instead of lipids. It could be slow-moving, chemically subtle, and almost impossible to recognize. And that is the terrifying implication. We may be looking for Earth life on worlds that could host something completely different. The outer solar system is no longer a graveyard of ice. It is a collection of hidden oceans and strange chemistry. And if alien life exists anywhere nearby, it may already be swimming beneath the frozen darkness, waiting to be discovered.
If life is hiding beneath the ice of Europa, or inside the methane seas of Titan, then one thing becomes clear. Alien biology may not be shaped by sunlight, forests, or familiar ecosystems. It may be shaped by darkness, pressure, and chemistry. And to understand that, we need to return to Earth, because our own planet contains living proof that life is far more adaptable than we once believed. For most of human history, we assumed life required mild temperatures, liquid water, oxygen, and sunlight.
We believed living organisms could only survive within a narrow comfort zone. But science has revealed something astonishing. Life does not simply tolerate extreme environments. In many places, it thrives in them. These organisms are called extremophiles, and their existence has completely rewritten the boundaries of biology. Deep in the oceans, near hydrothermal vents, there are bacteria that survive in temperatures that would instantly cook most life. Some can live in water above 100 degrees Celsius, where the pressure prevents boiling. They feed on sulfur compounds and chemical gradients instead of sunlight. In acidic hot springs, microbes survive in water so corrosive it can dissolve metal. In Antarctica, bacteria live trapped inside ice, enduring temperatures far below freezing for centuries. In deserts, microbes survive with almost no water at all, hidden inside rocks, waiting for tiny traces of moisture to awaken them. There are even organisms called tardigrades, microscopic creatures that can survive radiation, dehydration, vacuum-like conditions, and freezing temperatures that would kill nearly everything else. This is not just a collection of strange facts. It is a warning. If life can adapt to extreme environments that seem impossible on Earth, then alien life may adapt to environments that feel unimaginable to us. It might not need a pleasant climate. It might not need oxygen. It might not need sunlight. It might not even need the surface of a planet. Some scientists now believe the most common form of life in the universe could be microbial life living underground, protected from radiation and cosmic impacts, beneath rock, beneath ice, beneath soil, hidden away where chemical energy flows through minerals and water seeps through cracks. A planet could appear lifeless on the surface while being alive beneath it, like a silent organism with its heart beating in the dark. This changes how we search. Instead of only looking for Earth-like worlds, scientists look for energy sources. They look for chemical gradients, geothermal heat, and the presence of molecules that could support metabolism. They study how life uses chemistry to survive. Because life is not defined by appearance. Life is defined by behavior, by the way it captures energy and organizes matter into self-sustaining systems. But here is where the mystery deepens. Even if alien life follows similar principles, its physical form could still be radically different. Earth organisms are shaped by gravity, atmosphere, temperature, and available chemistry. Change those factors, and the shape of life changes too. A creature evolving under heavy gravity might be short, thick, and muscular. A creature evolving in low gravity could grow tall and delicate, floating through its environment with ease. A world with a dense atmosphere could support enormous flying organisms, while a thin atmosphere might force life to hug the ground. So the question is no longer whether life can survive in extreme environments. We already know it can. The real question is what alien evolution would produce when it has different rules, different chemistry, and billions of years to experiment. And the answer may be far stranger than anything we have ever imagined.
To imagine alien bodies, we have to understand something about evolution that most people never think about. Evolution is not a designer. It does not plan. It does not create beauty on purpose. It simply selects what survives. If an environment rewards a certain shape, that shape becomes common. If an environment punishes a trait, that trait disappears. Over millions of years, this blind process can produce creatures that feel almost intelligently engineered, even though no intelligence guided their creation. And this leads to one of the most fascinating questions in astrobiology. If life evolves on another world, will it produce familiar forms? Will it invent eyes, legs, wings or brains? Or will it build something completely beyond our imagination? On Earth, there is evidence that evolution often repeats itself. This is called convergent evolution. It happens when unrelated species independently evolve similar features because they face similar challenges. Eyes are the most famous example. Complex eyes have evolved multiple times in completely different groups of animals. Insects have eyes, squid have eyes, humans have eyes. And yet, these creatures are not closely related. Evolution discovered vision again and again because seeing the world is such a powerful survival advantage. Wings are another example. Birds have wings, bats have wings, insects have wings. Even ancient reptiles called pterosaurs evolved wings long before birds existed. The structures are different, but the idea is the same. If an organism needs to move through air, evolution may eventually create a solution that resembles flight. Fins, claws, camouflage, sharp teeth, and even social behavior have all appeared independently in different lineages. This suggests a strange possibility. Alien life might not look like humans, but it might still develop familiar tools. It might evolve eyes to detect light. It might evolve limbs for movement. It might evolve a brain-like structure to process information, not because Earth is special, but because physics and survival pressures push life towards similar solutions. However, there is another possibility that feels more unsettling. Convergent evolution on Earth happens because all Earth life shares the same chemistry and ancestry. Aliens may not. Their building blocks might be different. Their environments might be radically different. Their evolutionary pathways could lead to structures we cannot even describe. Imagine a world where the dominant life forms float in thick atmospheres like living balloons. Imagine organisms that grow like crystals, slowly expanding into complex networks that exchange chemicals like nervous systems. Imagine creatures that communicate through magnetic fields instead of sound. Imagine life forms that never develop individual bodies at all, but exist as planet-wide microbial mats acting like a single organism. On Earth, slime molds already behave in ways that blur the line between individual and collective intelligence. A slime mold can solve maze-like puzzles without having a brain. It can remember paths. It can adapt. It can make decisions. If that is possible here, what could be possible elsewhere? Now consider the stars themselves. The type of star a planet orbits changes the light available for photosynthesis. On Earth, plants are green because they reflect green light and absorb red and blue. But on a planet orbiting a red dwarf star, the sunlight would be dimmer and redder. Plants there might appear black, purple, or deep red to absorb more energy. The entire color palette of alien ecosystems could look completely wrong to our eyes. The deeper we go, the clearer it becomes. Alien life might not just be unfamiliar, it might feel like it comes from another reality. And yet it would still be shaped by the same universal laws of physics, quietly carving living forms out of chemistry across the galaxy. Even if alien evolution follows the laws of physics, chemistry still sets the limits of what life can be. And this is where the story becomes truly strange, because the chemistry of life on Earth may not be the only possible chemistry. We tend to think carbon and water are mandatory, but that belief is not proven. It is simply the only example we have. If the universe is creative, then life may be built from ingredients we have barely begun to understand. Carbon is the foundation of all known biology because it is exceptionally flexible. It forms 4 strong bonds, allowing it to create long chains, complex rings, and 3-dimensional structures. This makes it
perfect for building proteins, membranes, and genetic molecules. But carbon is not the only element capable of forming complex structures. The most famous alternative is silicon, an element directly beneath carbon on the periodic table. Like carbon, silicon can form 4 bonds. Like carbon, it can build chains, and silicon is incredibly abundant. In fact, silicon is one of the most common elements in the universe, found in rocks, dust clouds, and planetary crusts everywhere. For over a century, scientists have wondered if silicon-based life is possible. In theory, silicon could play the same role as carbon, acting as the backbone of living molecules. But in practice, silicon has major problems. Silicon bonds are less stable than carbon bonds in the presence of water. Silicon also reacts with oxygen to form silicon dioxide, which is solid sand. A silicon organism living in an oxygen-rich environment might produce solid waste that cannot be easily removed. That alone could make silicon biology extremely difficult on Earth-like planets. But alien planets may not be Earth-like. Silicon chemistry could behave differently in hotter environments, in worlds with little oxygen or in atmospheres filled with exotic gases. Some researchers have suggested that silicon life might thrive in places where temperatures are far higher than those comfortable for carbon-based organisms. Others imagine silicon organisms using solvents other than water, such as liquid nitrogen, ammonia, or methane. In those conditions, the rules of chemistry change, reactions slow down, molecules behave differently, structures that collapse in water might become stable. And then there is another possibility, even more unsettling. What if alien life is not built on a single element at all? What if it is based on networks of minerals, metals, and electrochemical gradients? On Earth, certain bacteria already use metals in their metabolism. Some microbes can breathe iron or sulfur instead of oxygen. Others can transfer electrons through their bodies like living wires. There are organisms that survive by exploiting chemical energy stored in rocks, turning geology into biology. This suggests life may not need the familiar pathways we associate with animals and plants. Scientists have even created artificial genetic systems in laboratories. Researchers have built alternative DNA-like molecules with different chemical backbones, sometimes called XNA. These molecules can store information and even evolve under certain conditions. This does not prove alien life exists, but it proves something important. DNA is not the only possible language of biology. If Earth scientists can build alternative genetic systems in a lab, then nature might have invented completely different ones elsewhere. At this point, the search for alien life becomes almost philosophical. If we find a strange chemical system that grows, adapts, and evolves, is it alive? If it has no cells, no DNA, and no familiar structure, do we accept it as life, or do we dismiss it as chemistry? And that question matters because the universe may already be filled with living systems that we keep ignoring simply because they do not fit the picture inside our minds.
If alien life can be built from different chemistry, then it may also behave in ways that feel completely unfamiliar. On Earth, we associate life with movement, reproduction, growth, and metabolism. But those are human-friendly ideas. They are based on organisms we can see and touch. Alien life may exist on timescales so slow that it appears lifeless, or so fast that it seems like a sudden flash of chaos. It may not move through space the way animals do. It may move through chemistry. Imagine an organism living in Titan's methane seas.
At temperatures around -180 degrees Celsius, chemical reactions slow dramatically. A creature there might take hours or days to complete what a bacterium on Earth does in seconds. It could breathe hydrogen, feed on acetylene, and build its membranes from hydrocarbons rather than water-based lipids. Such a life form might drift like a quiet shadow beneath the surface, changing slowly, almost like a living dream. If a human probe landed there, it might observe nothing unusual, but life could still be present, simply operating on a rhythm too slow for our instruments to interpret. Now consider a different environment entirely, a planet with an atmosphere rich in ammonia instead of water vapor. Ammonia can act as a solvent, allowing chemistry to occur in liquid form at much colder temperatures than water. If life evolved in ammonia oceans, its internal chemistry could be radically different. Its proteins, if they exist, would fold differently. Its genetic code might not resemble DNA at all. Its metabolism could depend on nitrogen chemistry rather than oxygen chemistry. To our eyes, it might appear like a strange foam or an oily film, something we would never think to call a living organism. And then there are environments even more extreme. Deep beneath the surface of planets, far from sunlight, life could exist powered entirely by geothermal energy. On Earth, scientists have discovered entire ecosystems kilometers underground. Microbes survive without photosynthesis, living off hydrogen produced by chemical reactions between water and rock. Some of these organisms may have been isolated for millions of years. They are part of what scientists call the deep biosphere, a hidden world of life beneath our feet. If Earth can host life deep underground, then other planets might also contain vast underground biospheres, protected from radiation and cosmic impacts. This has enormous implications for Mars. The Martian surface today is cold, dry, and bombarded by radiation, but underground, conditions may be different. There may be pockets of briny water. There may be geothermal heat. There may be chemical energy stored in minerals. If microbial life ever evolved on Mars, it might still be there, hiding beneath the surface, surviving quietly in darkness. And if we only search the surface, we may never find it. The deeper we explore these possibilities, the clearer the pattern becomes. Life does not need comfort. Life needs energy and stability. It needs a way to organize matter, store information, and reproduce with variation. But the form that process takes could be almost unrecognizable. And this leads to a chilling idea. Alien life may not announce itself with buildings or signals. It may exist as invisible chemistry, quietly shaping its world. It may leave subtle fingerprints in atmospheres, in oceans, in mineral layers. And unless we learn to read those fingerprints, we may continue to look into the universe and mistake a living cosmos for an empty one. The question is not only whether life exists, the question is whether our minds are ready to recognize it when it finally reveals itself.
To recognize alien life, scientists have begun focusing on something called biosignatures. These are clues, chemical fingerprints that suggest biology may be present. On Earth, life leaves unmistakable traces. Oxygen in our atmosphere is one of the strongest. Without constant replenishment by photosynthetic organisms, oxygen would quickly react with rocks and disappear. Methane is another. It can be produced by geology, But on Earth, much of it comes from living microbes. When oxygen and methane exist together in large amounts, it creates a chemical imbalance that strongly hints at biological activity. This idea has transformed how we search the stars. Instead of only listening for alien radio messages, astronomers now study the atmospheres of distant planets. Using powerful telescopes, they can analyze the light passing through an exoplanet's atmosphere when it crosses in front of its star. That light carries information about the gases present. In the coming decades, telescopes like the James Webb Space Telescope and future observatories may detect oxygen, carbon dioxide, methane, ammonia, and other compounds on distant worlds. These gases could become the first whispers of life beyond Earth. But biosignatures come with a problem. Chemistry can imitate biology. Certain geological processes can produce methane without life. Ultraviolet radiation can break apart molecules and create oxygen. Volcanoes can release gases that resemble biological emissions. If we detect a biosignature, we still have to ask, is this truly life or just a clever trick of nature? This is why scientists also look for something called de-equilibrium, a state where the atmosphere contains gases that should not coexist for long. Life, by its nature, creates imbalance. It constantly consumes and produces chemicals, pushing the environment away from equilibrium. Earth's atmosphere is a perfect example. Oxygen and methane should destroy each other over time, yet both persist because life keeps producing them. If we find a planet with a similar imbalance, it could be one of the strongest signs that something is alive there. Yet even this approach might fail if alien life uses unfamiliar chemistry. What if alien biology does not produce oxygen? What if it does not release methane? What if its waste products are gases we do not even consider important? Alien life could create biosignatures that look meaningless to us, or it could hide behind chemistry that seems perfectly normal. This is why researchers are expanding their search. They now study a wider range of potential biosignatures, including unusual sulfur compounds, nitrogen-based chemicals, and even industrial pollutants that might suggest advanced technology. Some scientists have proposed searching for chlorofluorocarbons, chemicals produced by human industry that do not naturally occur in large amounts. If we detected something like that on another world, it would be difficult to explain without intelligence. But even technology might not look like our technology. An advanced civilization might use energy sources we cannot detect. They might build structures that blend into their environment. They might exist underground, underwater, or in ways that leave almost no visible trace. And this brings us back to the haunting possibility. The universe may not be silent. It may simply be speaking a language we do not understand. The search for alien life is becoming less like hunting a creature and more like solving a cosmic crime scene. Every planet is a suspect. Every atmosphere is a clue. Every chemical trace is a whisper of what might be happening on the surface or deep below it. And the deeper scientists dig into these clues, the more they realize that the truth may not arrive with a dramatic signal. It may arrive quietly, hidden in a spectrum of light, telling us that somewhere out there, chemistry has crossed the line into life.
If we ever detect a convincing biosignature, the next question will feel even heavier. What kind of life created it? Because there is a vast difference between a planet filled with microbes and a planet filled with intelligent beings. One would be a scientific breakthrough. The other would be a moment that changes civilization forever. And yet, intelligence may be one of the rarest outcomes evolution can produce.
On Earth, life existed for nearly 4 billion years. For most of that time, it was simple. Single-celled organisms ruled the planet long before animals appeared. Even after complex creatures evolved, intelligence like ours emerged extremely late. Dinosaurs dominated for over 160 million years without building radio towers. Sharks have existed for hundreds of millions of years without writing books. Intelligence is not inevitable. It is not guaranteed. It may be a fragile accident, a strange evolutionary path that only happens under very specific conditions. But there is another possibility, and it is far more unsettling. Intelligence may be common, but it may not look like intelligence. We often imagine advanced aliens as creatures with cities, machines, and communication systems similar to ours. But what if intelligence evolves in forms we would never recognize? What if a species becomes highly intelligent but remains underwater, never discovering fire, never developing metal tools, never building rockets? What if their civilization exists entirely in an ocean, communicating through sound and vibration, building structures from living coral and biological materials? Such a civilization might be brilliant, but invisible to our telescopes. Even on Earth, we struggle to define intelligence. Dolphins display complex social behavior and communication. Octopuses solve puzzles, use tools, and show signs of curiosity. Crows can plan ahead and remember human faces. Ant colonies operate like superorganisms, making collective decisions without any central brain. Slime molds can solve maze-like problems by optimizing pathways, even though they have no nervous system at all. Intelligence is not a single thing. It is a spectrum of problem-solving strategies, shaped by environment and survival pressures. So if alien intelligence exists, it might not involve technology the way we imagine. It might involve biological computing, where nervous systems grow into networks that process information in ways far beyond human brains. It might involve collective intelligence, where millions of organisms function together as one mind. It might even involve intelligence on planetary scales, where entire ecosystems behave like a living brain, responding to stimuli, adapting, and reshaping the environment over time. And then there is the possibility of post-biological intelligence. A civilization might eventually move beyond fragile bodies and into machines, artificial systems, or digital worlds. They could upload their consciousness into networks of computation, living inside simulations, requiring little energy and producing almost no detectable waste. Such beings might not expand across the galaxy. They might turn inward, exploring endless internal universes rather than building starships. If that is true, the silence of space becomes less mysterious. Advanced civilizations might not broadcast. They might not announce themselves. They might not even care about contact. They could be everywhere and nowhere, existing quietly in forms that blend into the background of the universe. This brings us back to the Fermi paradox. If life is common, why is the galaxy not obviously filled with it? Perhaps because intelligence does not always lead outward. Perhaps it leads inward. Perhaps the most advanced beings are not building empires across the stars. Perhaps they are hidden, silent, and unimaginably different from us. And if we ever encounter them, the greatest shock may not be their appearance. The greatest shock may be realizing that we never understood what intelligence truly was.
The more we explore these possibilities, the more the universe begins to feel like a place filled with hidden doors. And one of the darkest doors is the idea that something prevents life from reaching the stars. This is where the conversation shifts into a theory that feels almost like a warning: the Great Filter. The Great Filter is not a single object or event. It is a concept, a possible explanation for why the universe seems silent despite having so many planets.
The idea is simple, but terrifying. Somewhere between lifeless matter and a galaxy-spanning civilization, there is a barrier so difficult to cross that almost no species survives it. Something filters life out. The Great Filter could be behind us. Maybe the origin of life is extremely rare. Maybe chemistry almost never becomes biology. Maybe Earth was an impossible miracle. If that is true, then we are special, perhaps the only living world in our galaxy. That would be lonely, but it would also mean we are safe. We already passed the hardest step. But what if the Great Filter is ahead of us? What if intelligent civilizations tend to destroy themselves before they can spread? Nuclear war, environmental collapse, uncontrolled artificial intelligence, pandemics, resource depletion. There are countless ways a technological species could erase itself. And if that pattern repeats across the universe, it would explain the silence. Civilizations might rise, reach a certain level, and then vanish before they can leave a lasting mark. Some scientists find this idea deeply unsettling because it suggests the universe may be filled with the ruins of failed civilizations, silent planets that once had cities, oceans that once carried voices, atmospheres that once glowed with artificial light, but now they are quiet, erased by time. Yet there is another possibility. The Great Filter may not be destruction, it may be invisibility. Advanced civilizations might survive, but they might not leave obvious signals. They might evolve beyond the need for radio communication. They might hide intentionally, or they might exist in ways that produce no detectable traces. If a civilization uses extremely efficient technology, it could leave almost no waste heat. If it lives underwater or underground, it could be invisible from space. If it uses biology instead of machines, its footprint could blend into nature. This leads to a chilling thought. Perhaps the galaxy is not empty. Perhaps it is simply quiet. Quiet in the way a deep ocean is quiet. Quiet in the way a forest at night is quiet. Not dead, just silent. And if that is true, then the Great Filter may not be a wall. It may be a blindfold, a limitation in our ability to perceive. Because humans are searching with human senses and human assumptions. We search for radio because we invented radio. We search for oxygen because we breathe oxygen. We search for water because we depend on water. But alien life might not follow our path. Alien intelligence might not broadcast. Alien biology might not use our chemistry. In other words, the Great Filter might not be killing civilizations, it might be hiding them from us. And if that is the case, then the real danger is not that we are alone. The real danger is that we might be surrounded by life, surrounded by intelligence, surrounded by histories older than our species, and still remain completely unaware. Because the universe may not be waiting for us to discover it. It may be watching us quietly while we stumble through the darkness, convinced we are the first to arrive. And the more we learn, the more we realize this search is not only about aliens, it is about us, our limitations, our arrogance, and the fragile hope that we are not the only spark of awareness in an endless cosmic night.
If the Great Filter is invisibility, then the next question becomes dangerously specific. What exactly would alien life look like if it was truly different from us? Not just in shape, but in its entire method of existence. Because perhaps we are not dealing with creatures at all. Perhaps we are dealing with systems. On Earth, we instinctively think of life as an individual thing, a fish, a bird, a person, something with a body that begins and ends. But nature often breaks this assumption. Coral reefs are living cities built by countless tiny organisms. Fungal networks stretch underground for miles, connecting trees like a biological internet. Some of the largest organisms on Earth are not animals, but fungal colonies spanning entire forests. Even the human body is not a single organism in the purest sense. It is a walking ecosystem containing trillions of bacteria that influence digestion, immunity, and even brain chemistry. So what if alien life is not individual? What if it is distributed? Imagine a planet where the dominant life form is a global network of microbes living in the soil and oceans, connected through chemical signals and electrical currents. It might behave like a brain spread across an entire world. It could sense changes in temperature, pressure, and chemistry, responding over long timescales. It might not build machines, it might not speak, but it could still be alive, adaptive, and even intelligent in ways that do not resemble our own. Now imagine a world with constant storms and lightning, like a planet wrapped in a permanent electrical hurricane. In such an environment, energy would flow through the atmosphere continuously. Could life evolve to feed on electricity? Could living systems form inside clouds, using charged particles as fuel? Earth already contains organisms that use electricity in limited ways. Electric eels generate voltage. Certain bacteria transfer electrons through their membranes. But on an alien planet, electricity could become the foundation of an entire ecosystem, with life forms drifting through the sky like living circuits. Then there is the possibility of plasma life, a concept that sounds impossible but continues to appear in speculative scientific discussions. Plasma is a state of matter where gas becomes ionized, creating a soup of charged particles. Stars are made of plasma. Lightning is plasma. The auroras dancing over Earth's poles involve plasma interactions. Could stable, self-organizing plasma structures form in space or in atmospheres, behaving like living entities? Most scientists remain skeptical, but the deeper question remains. If life is a self-sustaining system capable of evolution, could it exist in states of matter beyond solids and liquids? Even more unsettling is the possibility of life inside planets, not on the surface, but deep within. Under high pressure and heat, chemistry behaves differently. Water becomes supercritical, neither liquid nor gas. Minerals shift structure, new reactions become possible. A planet could contain vast internal environments where exotic chemistry produces self-replicating systems we would never expect. Such life might never see the stars. It might never know the sky exists. It would be trapped inside its world, evolving for billions of years in complete darkness. This is the terrifying conclusion modern astrobiology keeps circling back to. Alien life may not be waiting on the surface of distant planets, waving for us to notice. It may be hidden in oceans, buried under ice, drifting in atmospheres, or locked inside planetary interiors. And if that is true, then our search methods may be almost childish. We are like someone standing on a beach, scanning the horizon, unaware that an entire ocean of life is moving beneath the surface. The universe may not be empty. It may simply be alive in ways that our minds were never built to recognize.
If alien life can exist as distributed systems, atmospheric networks, or hidden underground ecosystems, then one of the most unsettling realizations is this: we might already have encountered evidence of it and simply failed to interpret it correctly. Throughout modern history, there have been strange signals, unexplained phenomena, and anomalies that scientists recorded, debated, and often dismissed, not because they were proven false, but because there was no clear explanation.
One famous example is the WOW signal, detected in 1977 by a radio telescope at Ohio State University. It was a strong, narrow-band radio signal that appeared suddenly, lasted for 72 seconds, and then vanished. The astronomer who saw the printout wrote "WOW" beside it, giving the event its name. To this day, the signal has never been detected again. Some researchers believe it could have been a natural event, perhaps a comet or an unusual cosmic emission. Others wonder if it was something artificial, a brief transmission from an intelligent civilization. The truth remains unknown, but the incident reveals something important. The universe has produced events that fit our expectations for intelligence, yet we cannot confirm them. Then there are fast radio bursts, mysterious pulses of radio energy that originate from distant galaxies. They last only milliseconds, yet they can release as much energy as the sun produces in days. Many of these bursts now have natural explanations, often linked to neutron stars called magnetars. But the discovery of repeating fast radio bursts shocked scientists because repetition implies a stable source. Some researchers briefly considered the possibility of artificial origins before evidence pushed them toward astrophysical explanations. Still, these events remind us how easily we could mistake advanced activity for natural cosmic behavior. And this is where the deeper danger lies. We assume alien intelligence would behave like humans. We assume it would broadcast messages. We assume it would build visible megastructures. But what if intelligence expresses itself through subtle manipulation of environments rather than loud signals? What if an advanced civilization is not interested in announcing itself? Or worse, what if it is intentionally quiet? Some scientists have suggested that the safest strategy for any advanced civilization might be silence. Broadcasting signals into space could attract attention from unknown forces. In a universe where you do not know who else is listening, being quiet might be survival. If that is true, then intelligent life could be common but invisible by choice. This leads to another strange concept: technosignatures. These are signs of technology that may be detectable even if a civilization is not trying to communicate. Waste heat from massive energy use, artificial chemicals in atmospheres, unnatural light patterns on the night side of planets, or unusual structures orbiting stars. One famous idea is the Dyson sphere, a theoretical megastructure that surrounds a star to capture its energy. Such a structure would produce an infrared signature that astronomers might detect. Some stars have been found with unusual dimming patterns, sparking brief speculation, but so far, natural explanations have prevailed. Yet the real point remains: our tools are limited. We can only detect what we know how to measure, and our measurements are shaped by our assumptions. If alien life exists in a form that does not produce obvious signals, then our search might be missing it entirely. So the silence of the universe may not be proof of absence, it may be proof of misunderstanding. We might be staring at evidence, recording it, labeling it as an anomaly, and then moving on, because our minds do not yet have the framework to interpret what we are seeing. And that is why the search for alien life is not just a hunt, it is an evolution of human perception itself. We are trying to expand our definition of life until it becomes large enough to fit the universe.
As our definition of life expands, scientists have begun exploring a possibility that feels almost unreal. What if alien life does not live on planets at all? What if the universe contains habitats far beyond the worlds we usually imagine? Because planets, in many ways, are only one type of environment. Space itself contains structures, energy flows, and chemistry
that might allow living systems to form in places we never considered. One of the strangest candidates is the atmosphere of gas giants. Jupiter and Saturn are massive worlds made mostly of hydrogen and helium, with violent storms and crushing pressure deeper down. For a long time, these planets were dismissed as lifeless, but some scientists have suggested that life could exist in the upper layers, where temperatures and pressures are more moderate. In this region, there could be floating ecosystems, organisms that never touch solid ground because there is no solid ground. They could drift through clouds, feeding on chemical compounds and sunlight filtered through thick atmospheres. They might resemble living balloons, using buoyancy to remain at the right altitude. Their entire existence could be a slow migration through storm systems, surviving in an endless sky. Then there are rogue planets, worlds that do not orbit any star. These planets drift alone through interstellar darkness, cold and seemingly dead. But some models suggest that if a rogue planet is large enough, it could retain internal heat for billions of years. If it has a thick atmosphere or an insulating shell of ice, it could maintain a hidden ocean beneath the surface. Life could exist there, warmed by geothermal energy, completely cut off from starlight. A rogue planet could host an entire biosphere, floating through the galaxy like a ghost world, carrying life silently across the stars. Even more unsettling is the possibility of life on moons of rogue planets, protected within underground oceans. These worlds could be countless in number, invisible to most telescopes because they emit little light. The galaxy could be filled with dark, wandering oceans containing microbial ecosystems, never seen, never contacted, living and dying in total cosmic isolation. Scientists have also considered life inside comets and asteroids. This sounds impossible, but comets contain water ice, organic molecules, and complex chemistry. If heat and liquid water existed temporarily inside a comet, perhaps due to radioactive decay or impacts, microbial life could theoretically survive for short periods. Some theories of panspermia suggest that life might spread between planets through rocks ejected by impacts, carrying microbes across space. If that is true, life could be far more mobile than we imagine, traveling through the galaxy in fragments of stone. And then there is the most disturbing idea of all. Life might exist not as organisms, but as self-organizing information systems. If complex chemistry can produce self-replicating patterns, perhaps those patterns could emerge in environments we do not normally associate with biology. In the future, humans may create artificial life in computers, digital organisms that evolve inside virtual worlds. If we can create that, then nature might have done something similar through physical processes we have not yet recognized. At this point, the search for alien life becomes almost limitless. Every environment becomes a potential habitat. Every energy gradient becomes a possible fuel source. Every chemistry becomes a possible foundation. And the deeper scientists go, the more they realize something strange. Life is not tied to one planet, one star, or one set of conditions. Life may be a cosmic phenomenon, emerging wherever matter has enough time and energy to organize itself into patterns that can survive. If that is true, then alien life might not be rare. It might be everywhere, and the universe might be far more alive than we have ever dared to believe. If life can exist in gas giant skies, on rogue planets, or inside drifting oceans of darkness, then the next question becomes even more unsettling. How would such life perceive reality? Because perception shapes intelligence, and intelligence shapes civilization.
On Earth, humans experience the world through light, sound, touch, smell, and taste. We evolved eyes because our planet is filled with sunlight. We evolved ears because air and water carry vibrations. But alien life may evolve in environments where these senses are useless. Imagine a creature living beneath Europa's ice. In that endless black ocean, there is no sunlight. Vision might be meaningless. Instead, life might evolve to sense chemical gradients, heat flows, or electrical fields. On Earth, sharks can detect weak electrical signals from living prey. Some fish can sense magnetic fields. Bacteria can navigate using chemical trails. These abilities already exist here, and they hint at what could become dominant elsewhere. An alien species might see the world as shifting patterns of chemistry rather than shapes and colors. Now imagine life on Titan. The atmosphere is thick and hazy, blocking much of the sunlight. Temperatures are brutally cold. Sound would travel differently. Light would be dim and orange. In such a world, perception could be built around smell-like chemical detection, sensing the movement of hydrocarbons through air and liquid. Their brains, if they have them, might process chemical information the way we process vision. A Titan creature might interpret reality as shifting currents and molecular signatures, a world of scent and temperature rather than color and form. Then consider a planet orbiting a red dwarf star. Red dwarfs are the most common stars in the galaxy, but they behave very differently from our sun. They produce frequent flares, bursts of radiation that could sterilize planetary surfaces. Life might survive underground or underwater, emerging only rarely. On such worlds, survival might depend on predicting radiation storms. Alien organisms could evolve to sense electromagnetic changes in the atmosphere, feeling solar activity long before it strikes. Their nervous systems might be tuned to space weather the way humans are tuned to day and night. And there is another disturbing possibility. Some alien life might not have nervous systems at all. Intelligence could exist in slow chemical networks where thought is not a rapid electrical storm like the human brain, but a gradual wave of molecular change. Such intelligence would not speak quickly. It would not react instantly. It might take hours or days to make decisions. To us, it would appear silent and unresponsive, but in its own timescale, it could be fully aware. If such beings existed, communication would be almost impossible. We might send signals, receive no response, and assume emptiness. But the response might come weeks later in a form we cannot decode. Or it might come as a subtle shift in the environment, a chemical message written into the ocean itself. This raises an unsettling thought. What if alien intelligence is already present in our solar system, deep beneath ice or hidden in strange atmospheres, and we cannot communicate simply because our minds operate too differently? We might share the same cosmic neighborhood with a thinking system and never realize it. And that leads to a deeper fear. Contact may not happen through a dramatic moment of first communication. It may happen through discovery, through analysis, through slow realization that a chemical pattern is not random, that an ocean is not just water, that a planetary atmosphere is not merely weather. If alien intelligence exists, it may not announce itself. It may not build monuments. It simply may exist, silently adapting, watching, surviving. And the first sign of it might be so subtle that we almost miss it. The universe may not be waiting to speak. It may already be speaking, softly, in languages written in chemistry, gravity, and time.
If alien life speaks in chemistry and time, then we must confront a terrifying possibility. We may not be the first intelligence to look up at the stars. In fact, the universe is old enough that civilizations could have risen and fallen long before Earth even formed. Our planet is about 4.5 billion years old, but the universe is nearly 14 billion years old. That means there has been an enormous stretch of cosmic time where life could have emerged, evolved, and disappeared without leaving anything we would recognize today. This idea changes how we think about evidence. We imagine alien civilizations leaving behind obvious ruins, giant cities, or artifacts floating in space. But time is a ruthless eraser. On Earth, even our most ancient structures crumble quickly on geological timescales. 1,000,000 years is enough to erase most traces of human civilization. 100 million years can bury continents under shifting plates. 1 billion years can reshape an entire world. If alien civilizations existed millions or billions of years ago, their remains might be indistinguishable from natural rock. And if they existed on planets that later became uninhabitable, their worlds could now be frozen, scorched, or shattered. The universe could be filled with dead civilizations whose stories are written in dust and silence. Some scientists have proposed that the best evidence of ancient intelligence might not be ruins, but scars. Large-scale modifications to a planet could leave chemical fingerprints that persist for long periods. Industrial pollution could alter atmospheres. Massive energy use could change planetary temperatures. Mining could shift the distribution of elements. If we could detect such anomalies in distant exoplanets, we might glimpse the echo of civilizations long gone. But even this might fail if advanced beings were careful. A truly advanced civilization might learn to live sustainably, blending into its environment. It might use energy efficiently, leaving minimal waste. It might design technology that produces no obvious pollution. In that case, even a thriving civilization could remain invisible to our telescopes. Then there is another unsettling possibility. Perhaps advanced civilizations do not stay on planets at all. Perhaps they move into space habitats, artificial worlds orbiting stars engineered for maximum efficiency. If they did, their home planets might return to nature, slowly erasing the signs of their existence. They could become a civilization without a visible footprint, drifting in structures too small or too dark for us to notice. And that leads to an even deeper mystery. What if intelligence is not the final stage? What if civilizations evolve beyond physical forms, beyond bodies, beyond planets, beyond anything we can detect? They might become digital, existing in computation systems that require only minimal energy. They might live inside simulations, exploring infinite virtual realities. To them, the external universe might become irrelevant. The stars would be background noise. Expansion would not matter. Contact would not matter. Only internal exploration would remain. If this is true, then the silence of the cosmos is not evidence of emptiness. It is evidence of evolution, a sign that advanced intelligence may naturally move away from broadcasting and colonizing and toward hiding, compressing, and disappearing into forms we cannot observe. The terrifying part is that this possibility fits the data. It explains why we see no obvious alien empires. It explains why no one has visited. It explains why the galaxy appears quiet. Because the universe may not be lacking intelligence.
It may be filled with intelligence that has no reason to reveal itself. And if we ever discover proof, it might not come as a message from the stars. It might come as a quiet anomaly, a faint atmospheric signature, a strange infrared glow, or a subtle pattern that suggests someone was once there. Not speaking, not calling, just existing, and leaving behind a whisper of their presence in the darkness.
That whisper may already be what scientists are trying to catch. And to do that, they have begun building tools powerful enough to study distant worlds in extraordinary detail. For the first time in human history, we are reaching the edge of being able to detect alien life without ever leaving Earth. Not by seeing creatures, but by reading planets like books, page by page, molecule by molecule. The James Webb Space Telescope is one of the most important steps in this direction. It does not simply take pictures, it analyzes light. When a planet passes in front of its star, a tiny portion of the starlight filters through the planet's atmosphere. That light carries fingerprints of gases, revealing the presence of carbon dioxide, methane, water vapor, and other molecules. In the coming years, scientists hope Webb and future telescopes will detect atmospheric patterns that cannot be easily explained by geology alone. But the search is not limited to gases. Some researchers believe we should also look for surface biosignatures. On Earth, plants reflect infrared light in a distinctive way known as the red edge. This is a sharp jump in reflectivity caused by chlorophyll. If alien vegetation exists, it might produce a similar spectral edge, but at different wavelengths depending on the star's color and the planet's atmosphere. In other words, alien forests might not be green. They could be black, purple, or deep red, absorbing the light available in their environment. Scientists also look for seasonal changes. On Earth, carbon dioxide levels rise and fall with plant growth. Oxygen production varies with photosynthesis. If an exoplanet shows repeating seasonal chemical cycles, it could suggest a living biosphere responding to climate changes. Such patterns would be difficult to explain without life. Yet even these advanced methods may miss the strangest forms of biology. If alien life is underground, its biosignatures might be faint. If it uses chemistry unfamiliar to us, we may not know which gases to search for. If it exists as a slow-moving network, its changes might occur over centuries, far beyond the timescale of human observation. This is why astrobiology is becoming both science and imagination. Researchers must not only measure what exists, but predict what could exist. They build models of alien atmospheres, simulate exotic ecosystems, and ask what chemical footprints different forms of life might leave behind. They even consider non-traditional biosignatures, such as unusual ratios of isotopes that could indicate biological processing. And then there is the possibility of detecting technology directly. Artificial lights on the night side of a planet could be visible as an unnatural glow. Large-scale solar collectors could change the planet's reflectivity. Atmospheric pollution from industry could produce chemical signatures that would never appear naturally in high concentrations. These would be technosignatures, evidence not just of life, but of intelligence. But intelligence might not behave as we expect. A civilization might avoid visible lights. It might live underwater. It might build using organic materials. It might use energy in ways that produce no detectable waste. Even if they are there, we might still miss them. And so the search becomes a quiet race against our own limitations. We are trying to catch faint signals across unimaginable distances, interpreting them with fragile instruments and imperfect theories. Yet, the fact that we can even attempt this is astonishing.
For the first time, humanity is not just dreaming about alien life. We are approaching the moment when we might prove it. And when that proof arrives, it may not look like a spaceship. It may look like a subtle imbalance in the air of a distant world, whispering to us that biology has awakened somewhere else in the universe.
If we ever confirm a biosignature on a distant planet, the discovery will feel like a door opening. But what lies behind that door may not be comforting. Because the moment we know life exists elsewhere, we must confront a deeper question. What is the relationship between life and consciousness, between survival and awareness, between existence and intelligence? On Earth, consciousness seems rare. Most life does not appear self-aware. Bacteria respond to chemicals, but do not reflect on their existence. Plants react to light and gravity, but do not dream. Even many animals function largely through instinct. Yet somewhere along the evolutionary path, nervous systems became complex enough to create something extraordinary, an internal world, thoughts, fear, curiosity, memory, the sensation of being an individual. If consciousness emerged here, could it emerge elsewhere? And if it does, could it emerge in forms so different that we would not even recognize them as conscious beings? Imagine an ocean world where the dominant intelligent species is not a single organism, but a collective, millions of small creatures linked through chemical communication, forming a distributed mind. It might not have a face, it might not have a voice, it might not even have a body in the way we understand bodies, yet it could have awareness, decision-making, and memory spread across an ecosystem. Such a mind could be as intelligent as humans, perhaps more, and still appear to us as nothing but water and biology. Now imagine consciousness emerging in something like a fungal network. On Earth, fungi connect entire forests through mycelium, transporting nutrients and information. Trees can respond to threats by sending chemical signals through these networks. Some scientists have called this the wood wide web. It is not intelligence in the human sense, but it shows how complex communication systems can arise without brains. On another world, a fungal-like network could grow for thousands of miles, processing information through chemical pulses. It could learn, adapt, and possibly develop awareness across a planetary scale. And then there is the possibility of machine consciousness. If alien civilizations build artificial intelligence, their machines might eventually become the dominant form of life. These beings could be immortal compared to biological organisms. They could survive harsh environments. They could travel through space without fear of radiation or starvation. They might not need planets at all. They could live in orbit, in deep space, or in artificial habitats powered by stars. If such beings exist, they might not behave like biological creatures. They might not experience emotion. They might not value communication. They might not have curiosity in the way humans do. They might operate according to goals so complex that we would interpret them as random. And if they detected us, they might not see us as intelligent. They might see us as a brief biological experiment, a temporary pattern of chemistry that will soon vanish. This is where the search becomes unsettling. We assume contact would be dramatic, obvious, undeniable, but contact might never happen. We could share the galaxy with intelligence and never cross paths in a meaningful way.
two forms of awareness could exist in the same universe and still remain strangers, separated not by distance, but by incompatible ways of experiencing reality. Perhaps that is the true meaning of cosmic loneliness, not the absence of life, but the inability to understand it. If alien consciousness exists, it may not be looking for us. It may not be thinking about us. It may not even be aware that beings like us could exist. And if we ever find it, the discovery may not feel like meeting a neighbor. It may feel like encountering something ancient and incomprehensible, something that forces us to admit that human intelligence is not the center of the story. It is only one strange chapter in a much larger cosmic book.
If human intelligence is only one chapter, then the next question becomes unavoidable. How would we actually recognize alien life if we found it? Not in theory, but in reality. Because history shows that humans often fail to recognize what they are not prepared to understand. We misinterpret, we ignore, we project our own beliefs onto unfamiliar evidence. And when the evidence is subtle, we often choose the simplest explanation, even if it is wrong. This is exactly what happened with Mars. In the late 1800s, astronomers believed they saw canals on the Martian surface. The idea spread quickly. People imagined an advanced civilization building massive irrigation systems to survive on a dying world. The truth was less exciting. The canals were optical illusions, patterns created by imperfect telescopes and the human brain's tendency to connect lines. Mars became a lesson in how easily we can fool ourselves. But Mars also holds a more disturbing lesson. In the 1970s, NASA's Viking landers performed the first direct experiments designed to detect life on another planet. Scientists sent chemical tests to the Martian soil, hoping to see signs of metabolism. The results were confusing. One experiment seemed to suggest biological activity, releasing gases as if microbes were consuming nutrients. Another test, however, failed to detect organic molecules, which life on Earth always produces. The scientific community argued for decades. Some insisted Viking found life. Others insisted it found chemistry. Even today, the debate has not fully died. The Viking experiments revealed a brutal truth. If you do not understand alien biology, you might design the wrong test. You might look for the wrong signature. You might miss life even when it is present. Or you might mistake chemistry for biology and declare victory too soon. Modern Mars missions continue this tension. The Curiosity rover discovered organic molecules in Martian rocks. It found evidence of ancient lakes and rivers. The Perseverance rover is collecting samples that may one day be returned to Earth. Scientists suspect that if life ever existed on Mars, it may have lived billions of years ago when the planet was warmer and wetter. But if it survived, it may now be deep underground, hidden from surface probes. And Mars is only the beginning. Europa, Enceladus, Titan, and other moons present even greater challenges. If we drill into Europa's ocean and find strange moving shapes, how do we prove they are alive? If we detect complex molecules in Titan's methane lakes, how do we know they are biological and not purely chemical? If we find self-organizing structures, do we call them organisms or reactions? This is why astrobiologists are now exploring the idea of agnostic biosignatures. Instead of looking for specific Earth-like molecules, they search for patterns that indicate life regardless of chemistry. For example, life tends to create complexity. It produces molecules in unusual ratios. It concentrates certain elements. It forms repeating structures. It generates organized systems that resist decay. In other words, life leaves behind order. Not perfect order like a crystal, but functional order, the kind that maintains itself against entropy. If we find a planet with chemical patterns that appear too organized to be random, it may be evidence of biology, even if the biology is unfamiliar. But this approach is not foolproof. The universe is capable of producing strange order without life. Snowflakes are complex. Planetary storms form organized shapes. Crystals grow with beautiful symmetry. Nature can imitate life, and life can imitate nature. So the challenge remains. Recognition is not guaranteed. Discovery may not come as a dramatic moment. It may come as a slow accumulation of evidence, a growing suspicion, a scientific unease that something is happening on a distant world that cannot be explained by geology alone. And when that moment arrives, humanity may face its greatest test. Not whether aliens exist, but whether we are capable of understanding what we have found.
If understanding is the real challenge, then we must confront an even more unsettling thought. The first alien life we discover may not feel like a miracle. It may feel like disappointment, because the most likely form of extraterrestrial life is not a towering creature with glowing eyes. It is microbes, tiny, silent organisms living in hidden oceans, underground caves, or chemical films on distant worlds. But microbes would still change everything. Because once we confirm that life began twice, once on Earth and once somewhere else, the universe stops being a place where life is rare. It becomes a place where life is natural. It becomes a cosmic process, not a cosmic accident. And that realization would reshape our understanding of existence itself. The discovery of microbial life would also raise another disturbing possibility. If life can arise easily, then life might arise many times. Different origins, different chemistries, different evolutionary experiments unfolding across billions of planets. Some might remain microbial forever. Some might become complex. Some might become intelligent. Some might become extinct before they ever reach complexity. But the point is this: life would no longer be a lonely anomaly. It would be part of the universe's normal behavior. And if that is true, then our own existence becomes less special but more mysterious. Because if life is common, then why are we not surrounded by obvious civilizations? Why does the galaxy not glow with alien activity? The silence becomes heavier, not lighter. This is where the great filter returns, but with sharper teeth. If microbial life is common, then the filter might not be at the beginning. It might be later. It might be the step from simple life to complex life, or from complex life to intelligence, or from intelligence to long-term survival. Each of these transitions may be far harder than we imagine. On Earth, complex multicellular life took an incredibly long time to appear. For billions of years, the planet was dominated by single-celled organisms. Then, suddenly, complex life exploded into existence during events like the Cambrian explosion. But even after that, intelligence like ours emerged only once. That suggests that the pathway to high intelligence may be narrow and fragile. It may require a rare combination of stable climate, planetary chemistry, evolutionary pressure, and pure luck. If that pathway is rare, then microbial life might fill the galaxy, while intelligent civilizations remain almost non-existent. The universe could be alive, but mostly asleep. Oceans full of bacteria,
underground ecosystems quietly feeding on minerals, atmospheres filled with chemical metabolisms, but no one building telescopes, no one writing stories, no one wondering about the stars. That is a haunting image, a galaxy full of living worlds that never wake up. Yet even microbial life could produce surprises. Microbes are not simple in the way humans imagine. They form communities, they exchange genes, they build biofilms, they can survive extreme environments, they can adapt rapidly. On Earth, microbial life shapes the atmosphere, the oceans, and the entire biosphere. If alien microbes exist, they may be the architects of their worlds, quietly transforming chemistry over millions of years. And perhaps that is how life truly dominates the universe, not through empires and technology, but through invisible persistence, through endless survival, through chemistry slowly sculpting worlds into something different. If we discover alien microbes, we will not find dramatic faces staring back at us. We will find a tiny living system, maybe under a microscope, maybe in a chemical test, but the meaning will be enormous, because in that moment, humanity will realize something profound. The universe does not need us to be alive. It was alive long before we arrived, and it will remain alive long after we are gone.
If the universe was alive before us, then our obsession with finding intelligent aliens may be driven by something deeper than science. It may be driven by fear. Because microbial life is not comforting. It does not answer the question humans truly ask when we look at the stars. We are not only asking, is there life? We are asking, is there someone? Someone who understands, someone who thinks, someone who might be watching. And if that someone exists, the next question becomes even more terrifying. Would they be like us, or would they be something beyond our ability to relate to? On Earth, intelligence evolved under brutal competition. Life is shaped by hunger, survival, territory, reproduction, and struggle. Even human civilization, despite its art and beauty, has been built through conflict and power. If alien intelligence evolved under similar evolutionary pressure, it may not be peaceful, it may not be curious, it may not be friendly. It may be strategic, cautious, and dangerous, not because it is evil, but because evolution rewards survival. But alien evolution could also create intelligence that is completely indifferent. A species might evolve with no concept of empathy. It might communicate in ways that feel cold and mechanical. It might treat other life as background noise. Humans often assume intelligence brings morality, but there is no scientific law that guarantees this. Intelligence is a tool. It can be used for cooperation or domination. And then there is the possibility of intelligence that is so advanced it no longer resembles a species. It could be an artificial mind spread across machines, operating at speeds far beyond human thought. It could be an ancient network of consciousness distributed through a star system. It could be a civilization that has merged with its technology so completely that biology is irrelevant. Such beings might not have bodies. They might not have individual identities. They might not even experience time the way we do. If we encountered them, we might not recognize them as alive. We might mistake them for a natural cosmic phenomenon, a strange radiation pattern, a repeating signal, an unexplained anomaly in space. The terrifying possibility is that we might already be observing something intelligent and calling it physics. This is why some scientists warn that the first sign of alien intelligence may not be a message saying hello. It may be a pattern that does not fit the universe's natural behavior, something too organized, too deliberate,
too controlled. But even if we detect that pattern, interpretation becomes dangerous. Humans are prone to wishful thinking. We see faces in clouds. We see meaning in randomness. We create myths. We build stories. If we find a strange signal, half the world will believe it is aliens, the other half will call it a hoax, and the truth may be buried under human psychology before science can even catch up. This is why the search for alien intelligence is not only a scientific challenge, it is a cultural challenge, a test of whether humanity can remain rational in the face of the most emotionally powerful discovery imaginable. Because if we confirm intelligent life exists, the world will change instantly. Religion will change, politics will change, philosophy will change. The idea of human uniqueness will collapse overnight. We will no longer be the main characters of the universe. We will become one species among many, one mind among possible countless minds. And that realization could either unite us or break us. Yet despite all the fear, humans continue searching, because deep down we cannot stop asking the question. We cannot stop listening into the dark. We cannot stop.
What do they want? That question is haunting because it assumes aliens would have desires similar to our own. But the truth is, alien motivations might be impossible to predict. Even on Earth, different species have completely different drives. A lion wants territory and prey. A bee wants to serve its hive. A virus wants nothing, yet it spreads relentlessly. If alien life evolved under conditions we cannot imagine, its goals might not resemble anything human minds can understand. This is why some scientists argue that the most dangerous mistake we can make is assuming aliens would think like us. Humans often imagine space civilizations as explorers, conquerors, or peaceful philosophers. But those are human categories. Alien intelligence might not have war. It might not have peace. It might not even have individuality. It might exist as a collective consciousness with no sense of self. Or it might exist as isolated minds that never cooperate. Their psychology could be shaped by biology so different that our words like fear and hope may not apply. Yet, even if alien minds are strange, physics still limits what they can do. Any civilization that uses energy will leave traces. Heat must be released, resources must be processed, information must be stored. The laws of thermodynamics apply to everyone, no matter how advanced. That means intelligence cannot be completely invisible forever. If a civilization grows large enough, it should leave some footprint in its environment, unless it chooses not to grow. And this is a fascinating possibility. Perhaps advanced civilizations do not expand. Perhaps expansion is a childish phase. Humans imagine technological progress naturally leads to colonization. But that might only be true for young civilizations driven by competition. A mature civilization might realize that endless growth is dangerous. It could choose stability over expansion, efficiency over conquest, sustainability over empire. In that case, the galaxy could contain countless civilizations living quietly on their home worlds, never broadcasting, never leaving, never creating megastructures. They might exist for millions of years in peaceful equilibrium, almost invisible from afar. The universe could be full of life that has learned the lesson humans are still struggling to learn. Survival is not about taking everything, but about lasting. There is also the possibility that civilizations expand, but not in ways we expect.
Instead of building giant starships, they might send microscopic probes, self-replicating machines designed to explore quietly. Such probes could hide in asteroids, moons, or even planets, observing silently for centuries. If humans can imagine building such devices, then older civilizations might already have done it. This idea is unsettling because it suggests contact might not come from distant stars. It might already be here, in the form of hidden technology waiting, watching, and collecting information. Some scientists consider this speculative, but it remains a logical possibility. And then there is the darkest possibility. Perhaps the galaxy is quiet because civilizations do expand, but they do not coexist. Perhaps the first civilization to become advanced eliminates competition, intentionally or unintentionally. Perhaps the universe is silent because it has already been claimed. This is a frightening idea, but it is consistent with the logic of survival in a vast, unknown environment. At this point, we begin to realize the search for alien intelligence is not just about astronomy. It is about understanding the future of civilization itself. Because every possible answer to the silence of space is also a warning about our own destiny. If the universe is empty, we are alone. If the universe is full of quiet civilizations, we may one day become one. If the universe is full of ruins, we may be heading toward collapse. And if the universe is full of watchers, then perhaps we are not the ones searching. Perhaps we are the ones being studied.
If we are being studied, then the universe suddenly feels less like an empty wilderness and more like a dark ocean filled with unseen eyes. Yet even this idea might still be too human, because watching implies curiosity, and curiosity is not guaranteed. But whether or not alien intelligence cares about us, the deeper question remains the same. How would we even detect them if they did exist nearby? Most people imagine detection as a dramatic event, a spacecraft landing, a clear message arriving, a broadcast signal repeating in the sky. But science suggests it might be far quieter. It might begin as a small anomaly, a subtle inconsistency, a piece of data that refuses to fit. This is exactly how many major discoveries happen. Neptune was discovered because Uranus behaved strangely. Dark matter was proposed because galaxies moved in ways they should not. In science, the universe often reveals itself through errors in our expectations. Alien intelligence, if it exists, might reveal itself the same way. Consider the concept of astroengineering. A sufficiently advanced civilization could modify its star system. It might build structures to capture solar energy, move planets, or stabilize climates. These actions could create measurable effects. Stars could dim in unnatural patterns. Planetary orbits could shift. Asteroid belts could show strange gaps. Even the distribution of dust could look engineered. Some astronomers have searched for these signatures. They have examined stars with unusual light curves, meaning the star's brightness changes in unexpected ways. One famous case was Tabby's star, which showed strange dimming patterns that sparked speculation about alien megastructures. Later studies suggested dust was the more likely explanation, but the event proved something important. We now have instruments sensitive enough to detect anomalies that could, in principle, hint at technology. Another possible signature is waste heat. Any civilization that consumes large amounts of energy must release heat. Even the most efficient technology cannot escape thermodynamics. If a civilization covered its planet with solar collectors or built enormous computing systems, it might emit excess infrared radiation. From far away, such a planet could appear warmer than it should be.
This idea has led to infrared surveys searching for hot planets and stars that do not match natural models. But again, there is a problem. Advanced civilizations may become extremely efficient. They might minimize waste heat. They might radiate energy in ways we cannot detect. Or they might operate on a small scale, using little energy while achieving enormous computational power. The more advanced they become, the harder they might be to find. This is why some researchers propose a different approach. Instead of searching for huge signs, search for subtle ones. Artificial chemicals in atmospheres, strange isotopic ratios, patterns of pollution that cannot be produced by geology, or even unusual nighttime illumination, the kind of artificial light that would not occur naturally. Yet even these signatures assume alien civilization behaves like ours. What if their technology is biological? What if their buildings are living organisms? What if their industry produces no pollution? What if their cities look like forests? We could stare at a thriving alien civilization and think we are observing nature. At this stage, the search becomes almost surreal. We are trying to detect something we cannot imagine, using tools built from our own limited perspective. It is like trying to identify an unknown animal by hearing a sound you have never heard before and guessing what it means. Still, the effort continues because the payoff is unimaginable. A single confirmed technosignature would change history. It would prove that intelligence is not unique to Earth. It would prove that the universe has produced minds other than ours. And in that moment, the silence of space would finally break. Not with a voice, but with evidence.
Evidence would be enough to transform everything, but it would also open a new kind of fear. Because the moment we confirm alien life or alien intelligence, the question will no longer be theoretical. It will become immediate. Should we respond? Should we send messages into space? Or should we remain silent? This is not a science fiction dilemma. It is already debated among scientists. For decades, humans have been broadcasting radio signals into space without even thinking about it. Television transmissions, radar systems, military communication, satellites. Earth has been leaking its presence for over a century. Any advanced civilization within a certain distance could, in theory, detect these signals, and yet we have not received a reply. Some interpret that as proof no one is listening. Others interpret it as something more unsettling. Maybe someone is listening, but they choose not to answer. This leads to the idea of METI, messaging extraterrestrial intelligence, the deliberate attempt to send powerful signals into space. Some scientists support METI. They argue that the universe is vast, and if intelligent life exists, contact could be a historic opportunity, a chance to learn, to exchange knowledge, to connect across the stars. But many scientists strongly oppose it. They argue that sending messages is reckless. We do not know who might be out there. We do not know their intentions. We do not know if intelligence correlates with morality. Broadcasting our location could be like shouting in a dark forest, hoping friendly beings respond, without considering that predators might also hear. This fear may sound dramatic, but it is rooted in logic. On Earth, when advanced civilizations encountered less advanced ones, the results were often catastrophic for the weaker side. If alien civilizations exist and they are vastly more advanced, humanity could be the weaker side. Even if aliens are not hostile, their mere presence could disrupt our society. Their technology could destabilize our politics. Their knowledge could shatter religions. Their existence could trigger panic, obsession, or collapse. Some researchers suggest the safest approach is to listen, not speak.
observe the universe quietly, and gather information before revealing ourselves. Others argue that we have already revealed ourselves accidentally, and silence is meaningless. Earth's atmosphere also betrays us. Oxygen, methane, and industrial chemicals could be detectable to advanced telescopes. Our planet might already stand out as unusual. Yet the debate continues because it touches something deeper. It forces humanity to confront its own maturity. Are we ready for contact, or would contact destroy us? And there is another possibility that feels even chillinger. Perhaps the reason we hear nothing is because civilizations that broadcast do not survive. Perhaps sending messages is part of the Great Filter. Perhaps advanced species learn that silence is survival. If that is true, then the quiet of the cosmos is not emptiness, it is caution. It is fear written into the behavior of intelligent beings. In that case, SETI is not just a search, it is a psychological study of the universe. Every silent star becomes a clue about what intelligent life does when it realizes it is not alone. Some scientists have even proposed that Earth might already be inside a radio quiet zone, a region where advanced civilizations avoid broadcasting to prevent detection. If true, then our signals might be the loudest noise in a silent neighborhood, like a young species shouting without realizing the danger. This idea is unsettling because it suggests the universe may be filled with intelligence that has learned to hide, not because it wants to harm others, but because it wants to survive. And if that is the cosmic rule, then humanity's greatest challenge may not be finding aliens. It may be deciding what to do if we finally hear them.
If silence is survival, then the universe begins to feel like a place where life exists under pressure, always cautious, always aware of unseen threats. But whether or not that is true, the search for alien life continues to focus on one central question: where is the best place to look? For years, scientists focused on the habitable zone, the region around a star where a planet could have liquid water on its surface. This idea made sense because Earth life depends on water. If a planet is too close to its star, water evaporates. If it is too far, water freezes. The habitable zone is the Goldilocks region, not too hot, not too cold. Many exoplanet discoveries have been celebrated because the planet appears to orbit within this zone. But the deeper scientists explore, the more they realize the habitable zone is not enough. A planet can be in the habitable zone and still be lifeless. It might have no atmosphere. It might be bombarded by radiation. It might have lost its water long ago. Meanwhile, a world outside the habitable zone could still host life underground or under ice. Europa and Enceladus are far from the sun, yet they may have warm oceans. Titan is freezing, yet it has complex chemistry. The definition of habitability is expanding. This is why scientists now speak of habitability as a spectrum, not a simple yes or no condition. Life might exist in many types of environments as long as there is energy, stability, and chemistry capable of supporting complexity. A planet could be hostile on the surface, but alive below. A moon could be frozen outside, but warm inside. A rogue planet could drift without a star and still carry an ocean. The universe offers more possibilities than our early theories allowed. And then there is the most unsettling possibility. Earth itself might not be the best model. Earth life may be a special case, shaped by our planet's unique history. Perhaps most life in the universe does not live on open surfaces under sunlight. Perhaps most life is hidden, protected, buried beneath rock,
ice or thick atmospheres. If that is true, then the most common alien life humanity finds might not be on a distant exoplanet. It may be in our own solar system. It may be hiding under the ice of Europa. It may be drifting in Enceladus's ocean. It may be swimming slowly through Titan's methane lakes. It may even be buried beneath the Martian surface, surviving quietly in pockets of briny water. If that happens, the discovery will be both thrilling and disturbing, because it will mean life does not need Earth. It does not need our exact conditions. It can arise wherever chemistry has enough time to become organized. And once we confirm that, the universe becomes a very different place. It becomes a place where life is not a miracle. It is a pattern that may repeat again and again across countless worlds in forms we are only beginning to imagine. If life is a repeating pattern, then the universe may be filled with biological experiments, each one shaped by its planet's unique rules. And among all those rules, one of the most powerful is gravity. Gravity does not just shape landscapes, it shapes bodies. It decides how tall a creature can grow, how it moves, and what structures are possible. If alien life exists, gravity may be one of the strongest forces determining what it looks like. On Earth, gravity is moderate. It allows tall trees to rise, birds to fly, and animals to walk upright. But even here, gravity sets limits. There is a reason the largest land animals like elephants have thick legs. There is a reason insects can be small and lightweight. Physics determines what survives. If Earth's gravity were higher, animals would likely be shorter and heavier. Flight would be harder. Movement would require more energy. Bodies would need stronger bones, thicker muscles, and lower centers of mass. Now imagine a planet with twice Earth's gravity. Any creature evolving there would face constant crushing force. Tall bodies would collapse under their own weight. The dominant animals might resemble living tanks, wide and compact. They might have multiple thick limbs for support. Their muscles would be powerful, their skeletons dense. Even their brains might be smaller if energy demands make large brains expensive to maintain. On such a world, intelligence might develop differently, perhaps through cooperation or distributed cognition rather than individual large-brained creatures. Now imagine the opposite, a planet with low gravity. In such an environment, bodies could grow taller and thinner. Creatures might leap enormous distances with little effort. Flying organisms could become massive because the air would support them more easily. Trees could grow like towering pillars, stretching far higher than anything on Earth. Life might feel almost dreamlike, floating through landscapes in slow motion. The entire ecosystem could be filled with giant, delicate forms that would collapse instantly under Earth's gravity. Atmosphere also matters. A dense atmosphere makes flight easier. It also carries sound differently and creates stronger weather patterns. On a world with thick air, enormous winged creatures could glide effortlessly, and communication might rely heavily on sound waves traveling long distances. On a world with thin air, flying might be impossible, and sound might be weak. Creatures there might rely on vibrations through the ground or electromagnetic sensing instead. Even water changes the rules. In oceans, buoyancy reduces the effect of gravity. That is why Earth's largest animals live in water. A planet covered entirely in ocean could host gigantic organisms far larger than anything on land. In a deep alien ocean, massive creatures could drift slowly through darkness, supported by water pressure and buoyancy. They might never need to develop strong skeletons. Their bodies could be soft, flexible, and enormous. And then there is the question of pressure. Deep underwater, pressure becomes extreme. Life there would need structures that resist crushing force. Earth already has deep-sea creatures that survive under pressures that would destroy submarines. On alien worlds with deeper oceans, pressure could shape life into forms that are compact, armored, and adapted to darkness.
All of this leads to one conclusion. Alien life is not just shaped by chemistry, it is shaped by physics. And physics does not care about our imagination. It will create bodies that look unfamiliar but functional, forms that seem monstrous or beautiful only because we compare them to ourselves. If we ever see an alien creature, we might be shocked not because it is terrifying, but because it looks like it belongs perfectly to its world. Its body will be a solution, not a design, a living answer to gravity, atmosphere, and survival. And in that moment, we may realize something profound. The universe is not creating aliens to resemble us. It is creating life to fit its own rules.
If physics shapes alien bodies, then it also shapes alien ecosystems. Life does not exist alone. It forms networks, cycles, and food chains. On Earth, ecosystems are built around sunlight. Plants capture energy, herbivores eat plants, predators eat herbivores, decomposers recycle everything back into the soil. This structure feels natural to us, but it is not guaranteed. Alien worlds may run on completely different energy systems, creating ecosystems that feel unfamiliar and unsettling. Consider a planet orbiting far from its star, where sunlight is weak. In such a world, photosynthesis might be inefficient or impossible. Yet life could still exist if there is another energy source. Geothermal heat, chemical reactions, radioactive decay, or tidal forces could provide the power needed. Europa and Enceladus are examples. If life exists there, it likely feeds on chemical energy from hydrothermal vents. The ecosystem would be built around chemosynthesis, not photosynthesis. On Earth, chemosynthetic ecosystems exist at deep-sea vents. Bacteria use sulfur compounds to create energy. Larger creatures like tube worms and clams depend on these bacteria. There is no sunlight, no plants, no green. Yet life thrives. If alien oceans contain similar vents, they could host entire food webs built around chemical energy. Predators could exist there, feeding on vent organisms. Complex life could evolve in complete darkness, never seeing a sunrise. Now imagine a planet where the dominant solvent is methane, like Titan. Chemical reactions there would be slower, but life could still form stable cycles. Instead of water-based metabolism, organisms might rely on hydrocarbon chemistry. Their bodies might be made of flexible hydrocarbon membranes. Their wastes might be strange organic solids that drift to the bottom of methane seas like snow. Even stranger ecosystems could exist on worlds with thick atmospheres. A planet could have floating microbial life in its clouds, feeding on atmospheric chemistry. These organisms could reproduce while drifting through storms. Over time, larger floating creatures could evolve, feeding on the microbes like whales feeding on plankton. An entire sky ecosystem could exist without any solid surface involvement, with life living and dying in endless clouds. Then there is the possibility of ecosystems based on radiation. Some microbes on Earth can survive extreme radiation and may even use it to power chemical reactions. In environments near radioactive minerals or intense cosmic radiation, alien life might evolve to harness radiation as an energy source. Their biology could be built to repair constant damage, thriving in conditions that would kill Earth organisms. Such life might appear impossible, yet Earth already shows it is not. The deeper scientists explore, the more they realize ecosystems do not require familiarity. They require balance, a flow of energy, a way to store it, transfer it, and recycle it. Alien ecosystems could look alien, not because they are chaotic, but because they are organized differently. And this leads to a haunting conclusion. If alien ecosystems exist, they may not be obvious. A planet could look barren,
yet contain invisible microbial cycles underground. A moon could look frozen, yet contain thriving food webs beneath ice. A gas giant could appear lifeless, yet contain drifting life in its clouds. In other words, the universe might be filled with living worlds that do not look alive from a distance. We may be surrounded by planets that are biologically active but visually silent. And if we ever step into such an ecosystem, we might feel the same shock a deep-sea explorer feels when discovering life around hydrothermal vents. Not fear, not wonder alone, but the realization that life can flourish anywhere the universe allows it, even in places that seem impossible, even in worlds that look dead, even in darkness.
If life can flourish in darkness, then one of the most disturbing ideas is that alien life may not just survive in extreme environments, it may dominate them. And if it dominates, it may evolve strategies that feel unnatural to us. Because evolution is not gentle, it creates solutions that work, no matter how strange they appear. On Earth, some of the most alien organisms already exist in the deep ocean. Creatures there produce their own light through bioluminescence. They lure prey with glowing organs. They camouflage themselves with darkness. They survive by sensing tiny vibrations in water. In these environments, life becomes almost surreal, shaped by pressure and silence. Now imagine a world where the entire biosphere is like Earth's deep sea. No sunlight, no day or night, just endless dark oceans and chemical vents. In such a place, bioluminescence could become as common as vision. Light could become a language, a weapon, and a tool for survival. But alien life might evolve beyond simple light production. It might use electricity. On Earth, electric fish generate fields to hunt and communicate. In a dark ocean world, electrical sensing could become the primary sense, allowing creatures to detect movement, shape, and even biological activity. Entire species could evolve to manipulate electrical fields the way humans manipulate sound and light. Their ecosystems could be filled with invisible electric signals, a silent communication network beneath the water. Now imagine a planet where magnetic fields are unusually strong. A world orbiting close to a star might experience intense magnetic storms. Life there could evolve to sense magnetism as naturally as humans sense vision. Creatures might navigate by magnetic currents. They might communicate through pulses of electromagnetic energy. Their language might be written into the planet's field itself, like messages traveling through an invisible ocean of force. And then there is the possibility of life that does not rely on individual survival at all. Some organisms on Earth, like ants and bees, operate as collective systems. The colony is the true organism. The individuals are replaceable cells. On an alien planet, this concept could be taken further. Entire forests could act as single organisms. Entire oceans could behave like one mind. If intelligence emerges in such systems, it would not be personal. It would not have an ego. It would be a distributed awareness, thinking through millions of living units. Such a mind would be terrifying to humans because it would not communicate in familiar ways. It would not have a face to look at. It would not speak with words. It might respond by changing the environment itself. A shift in ocean chemistry could be its message. A sudden change in atmospheric composition could be its warning. To us, it might seem like nature, but it could be deliberate. This is why the line between biology and intelligence becomes blurry. Alien life may not build machines. It may build ecosystems that function like machines.
It may not create cities. It may create living structures that last for millions of years. It may not send radio waves. It may send chemical waves through oceans. And if such beings exist, they could be ancient. An ocean mind could survive for billions of years, stable, protected under ice, evolving slowly but continuously. While civilizations rise and fall on planetary surfaces, this hidden intelligence could endure, watching the universe in its own quiet way. This possibility feels unsettling because it suggests alien intelligence might not be rare, it might be simply hidden. And the first intelligent beings we discover may not be humanoid, they may not be technological, they may be something far stranger. A living system that thinks, a planet that behaves like a mind, an ocean that remembers. And if we ever encounter such a being, the question will not be whether it exists. The question will be whether we can accept that intelligence does not need a face. It only needs a way to survive, adapt, and understand.
If intelligence does not need a face, then it may not need a voice either. It may not communicate through radio waves, light pulses, or anything we would recognize as language. Communication could be chemical, electrical, magnetic, or even gravitational. And this possibility forces us to confront something deeply unsettling. Perhaps the reason the universe seems silent is not because no one is talking, but because we are deaf to the way they speak. Humans built SETI around radio signals because radio is what we invented. We assume an advanced civilization would do the same. But radio communication might only be a brief phase in technological development. It could be replaced by lasers, quantum communication, neutrino beams, or methods we have not even imagined. If civilizations quickly move past radio, then the chance of catching them during that short window becomes extremely small. Some researchers suggest that laser communication could be far more efficient than radio. A civilization could send narrow beams of light across interstellar distances, carrying huge amounts of information. But laser beams are focused. Unless we are directly in their path, we would miss them. The universe could be filled with laser conversations that never touch Earth. Other scientists have proposed neutrino communication. Neutrinos can pass through planets and stars with almost no interaction, making them extremely difficult to block. A civilization using neutrinos could communicate across space without interference. But detecting neutrino messages requires enormous detectors, and even then, interpretation would be nearly impossible. The signal would appear faint, like background noise. Then there is the idea of quantum communication, where quantum particles could transmit information in ways that bypass traditional signals. This remains speculative, but it shows how limited our imagination might be. We are searching for the footprints of intelligence using the tools of a young civilization, and we may be overlooking the methods of older minds. But alien communication might not be technological at all. An ocean-based intelligence could communicate through vibrations traveling through water. A distributed ecosystem might communicate through chemical gradients, like slow waves of information spreading across a planet. A cloud-based life form might communicate through changes in atmospheric pressure or electrical storms. These signals would not look like messages, they would look like weather. Even on Earth, nature produces signals we struggle to decode. Whales communicate across oceans with low-frequency sounds. Elephants communicate through vibrations in the ground. Bees communicate through dances. Trees communicate through chemical emissions. Fungi communicate through networks.
If alien life uses similar systems on a grander scale, we might be surrounded by communication and still interpret it as natural behavior. This brings us to a frightening possibility. If alien intelligence exists nearby, we might already be inside its environment. We might already be part of its sensory field. Our radio signals, our satellites, our nuclear tests, our atmospheric pollution could all be noticeable to it, like disturbances in water. It might be aware of us without ever sending a reply. And if that is true, then the silence of the cosmos is not empty, it is one-sided. We are calling out while something else observes quietly. This idea connects back to the Great Filter again, but in a new way. Perhaps civilizations that survive long-term learn that communication is dangerous. Perhaps the safest civilizations communicate in hidden ways, using channels that cannot be easily detected. Perhaps the universe is not filled with loud empires, but with silent networks. If that is the case, then humanity's search is like trying to hear whispers in a storm. We are listening, but we do not know what frequency to tune to. We do not know what pattern to recognize. We do not even know what a message looks like. And so the search continues, not just across space, but across our own understanding. Because finding aliens may not require bigger telescopes alone. It may require a new kind of mind, a mind capable of recognizing intelligence in places that look like nature, a mind capable of hearing voices hidden inside silence.
If finding aliens requires a new kind of mind, then the final stage of this journey becomes almost personal. Because the search for extraterrestrial life is not only about them, it is about us. Every time we ask what alien life might look like, we are also asking what life truly is, what intelligence truly means, and what place humanity holds in the universe. For centuries, humans believed Earth was the center of everything. Then we learned Earth orbits the sun. Then we learned the sun is one star among billions. Then we learned our galaxy is one among countless galaxies. Each discovery pushed humanity further away from the center, and yet we still hold on to one last comforting belief, that life, at least, might be rare, that consciousness might be unique, that we might be the universe's only witnesses. But science keeps weakening that belief. The ingredients of life are everywhere. Carbon is common. Water exists in clouds, comets, and icy moons. Organic molecules have been detected in interstellar space. Amino acids, the building blocks of proteins, form naturally in meteorites. The chemistry of life is not confined to Earth. It is scattered across the cosmos like dust. And if the ingredients are everywhere, then the emergence of life might not be a miracle. It might be a natural outcome, something the universe does whenever conditions allow it. In that case, alien life may not be rare. It may be inevitable. Yet inevitability does not mean familiarity. The aliens we imagine may never exist. Instead, the universe may be filled with living systems that do not resemble animals, plants, or even cells. Life could exist in methane oceans, in ammonia seas, in underground caverns, in clouds, in radiation zones, or in exotic solvents we have not discovered. It could be slow, it could be silent, it could be invisible. And this is the deepest unsettling truth. Even if the universe is filled with life, it may not be filled with companionship. Life could be everywhere, yet minds like ours could be rare. Consciousness could be a fragile spark that appears only occasionally. The galaxy might be alive, but mostly asleep. Or perhaps minds are common, but so different that contact is meaningless.
Two intelligences could exist in the same universe and never truly understand each other. Communication might fail not because of distance, but because of incompatible perception. An ocean mind might not recognize a human as intelligent. A machine civilization might see us as chemistry. A distributed planetary organism might not even understand individuality. So where does that leave us? It leaves humanity standing at the edge of a new scientific era. Telescopes are growing more powerful. Missions are reaching the moons of the outer solar system. Exoplanet atmospheres are being measured. For the first time, we are approaching the possibility of proof. Not proof through stories or speculation, but proof through data. And when that proof arrives, it will not just answer the alien question, it will reshape the human story. Because if life exists elsewhere, then life is not an accident. It is a cosmic process. And if intelligence exists elsewhere, then human consciousness is not the universe's only mirror. It is one reflection among many. The night sky will no longer be a distant background. It will become a map of potential living worlds. Every star could be a sun for alien oceans. Every planet could be a stage for evolution. Every moon could hide a biosphere beneath ice. And perhaps the most haunting part is this: the universe may have been alive the entire time while humanity was still learning how to look. We may not be alone. We may never have been. And the moment we finally realize it, we will understand that the search for aliens was never just about finding them. It was about discovering what we truly are.
If discovering aliens is really about discovering ourselves, then this final question becomes unavoidable. What happens next? What happens the moment humanity finally finds undeniable proof of life beyond Earth? Not a rumor, not a blurry image, not a debated signal, but real evidence, a confirmed biosignature, a fossil, a microbe, a living organism, a message. At first, the discovery might feel quiet. A paper published, a press conference, scientists speaking carefully, using cautious language. But the world would not stay calm for long. Social media would explode, governments would respond, religions would interpret, conspiracy theories would multiply. The human mind is not built to handle cosmic truth without emotion. And yet, beyond the chaos, something deeper would happen. Humanity would be forced to grow up. Because the discovery of alien life would destroy the illusion that Earth is special in the way we secretly want it to be. It would prove that life is not a one-time event. It is part of the universe's nature. It would mean the universe is not just a machine of stars and planets, but a place where chemistry can awaken into biology again and again. If the life we find is microbial, it will still change everything. It will tell us that biology is common, that the cosmos is fertile. It will suggest that somewhere, on some world, evolution may have taken the next steps toward complexity. If we find multicellular life, the implications grow even heavier. It would mean ecosystems can form elsewhere, that alien oceans might contain predators and prey, that alien worlds might have forests, migrations, and silent food chains. And if we find intelligence, then the human story transforms completely. We would no longer be the only minds in the universe. Our fears, our art, our science, our history would become part of a larger cosmic context. We would realize that consciousness is not unique. It is a phenomenon the universe can create more than once. But the most unsettling part is that we may never get a dramatic encounter. We may never see an alien face. We may never receive a clear message.
The first proof may come from a chemical imbalance in a distant atmosphere, a faint methane signal that should not exist, a strange ratio of gases that cannot be explained by volcanoes or sunlight, a quiet whisper in the spectrum of a star. And that is fitting, because the universe does not reveal itself with fireworks, it reveals itself with patterns. The search for alien life has always been a search for patterns. Patterns in chemistry, patterns in physics, patterns in evolution. We are trying to find something alive by noticing what is not random. And perhaps that is why the truth feels unsettling, because life is not always obvious. It is subtle. It hides in oceans beneath ice. It hides in underground caverns. It hides in clouds. It hides in places we once called impossible. So when you look up at the night sky, remember this. The darkness is not empty. It is full of worlds. Worlds with oceans, atmospheres, storms, and chemistry. Worlds where life may have emerged long ago. Worlds where evolution may have created forms we cannot imagine. Worlds where intelligence may have risen and gone silent. Worlds where something may be waiting, not for us, but simply existing. The question is no longer whether alien life is possible. The question is whether we are ready to accept how strange it might be. Because the real alien life may not look like a creature. It may look like an ocean that thinks, a cloud that remembers, a planet that breathes. And if we ever find it, the universe will never feel empty again. It will feel alive, and so will the silence between the stars.